Hey guys, what's up? My name is Gabe and this is Games with Gabe. This is the next tutorial in the Geometry Dash series. If you remember from the last tutorial, we got to a point where we have this grid and we can middle mouse click the scroll button and we can move around the scene. So that's cool, but we can't really place anything into the scene. So this is what this tutorial is going to be about. We're going to be having a preset sprite attached to the mouse that snaps to the grid, and then we can click it and place it inside of any one of these grid patterns as far as we want. So we'll be getting that done. We're gonna need this sprite sheet, so I'm gonna link this in the description. It looks like this, and it's just a simple sprite sheet that I made, and it'll be for some of the blocks that we'll be placing in the future. So before we do this, I just want to go over, draw some of the things, because I feel like I haven't done that in a while, and it is important. So let's draw this out, see how it actually works before we go and code this. In our game currently, we have these grids that are all in this space, and they're all 42 by 42. And basically what I want to do is I want the mouse to have a grid attached to it, so like some sprite that is just being dragged around with it, and this sprite will be snapping in to each grid square. So if it's over this, anywhere over this grid square, then the grid or the sprite should snap right into there. And basically as we move the mouse across the screen, it will snap into the appropriate grid place on the screen. And then when we click, what I want to happen is for a new game object to be created and then placed exactly in the screen. How do we get the X and the Y? Well, that's really simple. We just take the mouse's X and Y on the screen and say we have a camera positioned here. Then we can say this X and Y in world space is the camera's X and Y, which is right here, plus the mouse's X and Y, which is right here. And then we can get the world space for this point, which would be like some world X and world Y. Once we have this world X and world Y, we can divide it by the grid width. So if we say world X divided by the grid width, and we do integer division, that means that it will clamp it so that it'll be like 1, 2, 3, 4, or 5, depending on how many grids it is. So like say this was grid 0 over here, then this would be grid 0, 1, 2, 3, 4, so on and so forth. And then it would give us whatever number this is. So then if we multiply this by that grid width, then we will end up getting the exact X of this position in world coordinates. And then we can do the same thing for the Y position, and that will give us the Y position, and then we can figure out exactly where to place our object and everything. So that's basically what we're going to be doing. It's very similar to how we actually drew the grid, but I didn't really go over that in detail, and I just wanted to go over it in a little bit of detail, draw it out just a little bit so that we have clear understanding of what's going on there. The first thing that we're going to be doing is we're going to go into our component, and we will create a new class called snap2grid. And so we will add this to Git, and then inside of here we're going to need a sprite. So we'll say public sprite. This is going to be whatever sprite is currently attached to the mouse, and right now that is null. And then what we're going to do is we're going to have a couple more debounce time. So debounce equals 0.0 f private, and this is a float. Sorry, there we go. Debounce left equals 0.0 f, and then we're going to actually reset. Well, no, this is debounce left, sorry. This is debounce time. And then this one we're going to set to 0.2. And this is just that if the user presses, it only registers one click. So every 0.2 seconds, it will register another click, because we don't want them to press and then just have it like spamming blocks everywhere, which wouldn't be good. Okay, and then we will extend component with this class. And we will import this. That's another thing real quick. Before we continue, let's do this really neat thing that I figured out. So if we go to our file and then our project properties, which should be, there we go, settings. And then if we go into the editor, so right here we have editor, and then go to auto import. And then if we change this to optimize imports on the fly for the current project, then this will import them automatically. And so it also adds unambiguous imports on the fly. So if it can find out exactly which import it should be, it will just add it automatically. And then we'll have to go down to code style, Java, and then there's this thing called use single class import, and that is the one that we want to use. This just makes sure that it only imports a single class and doesn't import the whole the star class name, which is really annoying because it keeps doing that. So that's good. Should fix the issue. We'll see if that works. Continuing with the tutorial now. So we have this debounce time to make sure that they don't accidentally click multiple times when they're not trying to. We'll override in here the update method. So we'll say public void update double delta time. And then we're going to be doing quite a few things in there. And we will have a draw method. So public void draw graphics 2D G2. And so this one is actually going to be probably better to do first. So what we'll do in here is we'll say sprite equals parent.get component. Well, actually, we could have it here. I'm going to do it as part of the game object instead. So this will be an actual game object. So the sprite will be game object.get component sprite.class. And then we'll just leave that. So then we can say if the sprite does not equal null. And the reason we're having this as a game object is because we'll eventually be able to add several components to this and then copy the entire game object to the place on the screen so that when we're placing objects, it comes with the box bounds and whatever else the game object may need to contain. So then we'll say if the sprite's not null, we want to draw it. I'm going to give it a little bit of alpha too. So it's a little bit transparent until they place it, which just makes it so that when you actually see it placed, it actually makes sense. So in order to do this, you need this thing called an alpha composite, which is part of it. And you see it imported automatically, which is really nice. So this will be called AC. And we'll say equals alpha composite dot get instance. And then we'll say alpha composite dot source over. So we're just going to be doing the alpha over the entire image. And then we'll say alpha, which means we're just applying this alpha to the entire image. So then we say g2.setComposite. We want to composite this alpha source over whatever we're drawing right now. And let's say g2.drawImage. We'll say sprite.image. And then we will say int GameObject.transform.position.x, int GameObject.transform.position.y. And then we will say, do the sprites have widths? They do. We'll just say sprite.width and sprite.height. Make it simple. And I think these need to be cast to integers as well. So we'll say int and int there. And then we need to put null for the image observer. So no image observer. There we go. And then we will say g2.setComposite AC. And we need to reset the AC. Okay, so we need to reset the alpha composite afterwards. I'm going to copy this real quick. Just copy that and then paste it here. And then we will say alpha equals 1.0. And then just delete this so that we're not redeclaring the same variable. Then we set the alpha back to 1.0 and we draw it. So that way, whenever future things go to use the graphics handle, they don't end up drawing everything in half transparency. So that should be good for that. And it's not going to be drawing it in the correct place though, currently, because we have not actually updated the game object's position in the X position or the Y position. So what we need to do in our update method is basically track the mouse and then do that thing I was talking about where we snap it to each individual grid line. So we'll go into our update method and we will say if this.parent or this.gameObject, I'm sorry, keep referencing old code, .get component sprite.class does not equal null. So if we are holding something, then we want to start tracking the mouse with this game object. We will say float x equals, and then do something very similar to what we were doing with the grid lines. We'll say math.floor, and then we'll say the window.getWindow.mouseListener.x plus the level editor scene dot, well, we don't have that, the window.getWindow.camera or .get current scene .camera .position .x. Okay, which is quite a mouthful. We may actually end up changing a little bit of that too, just to make it a little bit easier to access and everything in the future. But plus the window.getWindow.mouseListener.dx over the grid width. And we want this all to be contained inside of this guy. So this will snap it, and the grid width is going to be initialized when we create this. There we go. So we'll go up here, and when we're creating a snap to grid, we need to supply it with the grid width and the grid height, which will be the same grid width and grid height as we are using for the actual grid. So then we will go into here and we'll say int grid width and grid height. And then we will just initialize those in here. Equals grid width. And then this dot grid height equals grid height. Okay, so that should snap it. So we say get the mouse listener's X, add the camera's position X, just like I said. And then we add the DX too. So how far has the mouse traveled if they're dragging? Then we divide that by the grid width to figure out which position they are in. Okay, and then actually I'm gonna copy that because the Y is basically the same, just all Ys. So we'll do that, and then we will change every X to a Y. Change that to a Y. Change that to a Y. And change that to a Y. Okay, cool. So now we have the X and the Y, and then we basically just want to set this guy to have that X and Y. But we need to, so this is the X and the Y snapped as an integer. So it's not the actual world X and world Y yet. So we're gonna have to transform it as we set it. So we'll say this dot game object dot transform dot position dot X equals X times grid width, because we need to transform it to the world coordinate minus the level or the window dot get window dot camera dot get scene dot camera dot position dot X. Okay, there we go. And then this just transforms it so that it's local to the window. But this will give it the world space and then transform it to the correct position on the actual window. So then we'll say the same thing for the Y. Just copy that and paste it. So let's say Y, change that to Y, and change that to Y. There we go. That should give it the correct X and Y. Now let's see if this is actually working or not. Let's go into our level editor scene. What we're going to do is we're going to load in that sprite sheet first of all. So go down here, and I will say sprite sheet objects equals a new sprite sheet, and we're going to give it the picture file, which is assets slash, I think it's just sprites or something. Okay, yeah, assets slash sprite sheet.png. And then we're going to give it the tile width, which is 42, tile height 42, spacing is 2, I believe. So 6 columns, and then size, there's 12 objects in there. Then we'll go sprite, mouse sprite equals objects dot get dot sprites dot get 0. So we'll just get one of those objects, and then up here we will create a snap to grid, and we will just call it snap to grid. And down here, we'll say snap to grid. This is actually going to be a game object too. It's not just going to be, we'll call this too just the mouse cursor, just to give it some more explicitness, because that is what this is. It's just going to be attached to the mouse cursor. So we'll say the mouse cursor equals a new game object, and then we're going to give it mouse cursor transform new vector 2. It doesn't matter because it's going to be changing anyway. So we need to wrap that in new transform as well. There we go. Okay, so we create the game object and we say mouse cursor dot add component new snap to grid, and then we need to give it the grid width and the grid height, which is constants dot grid tile width constants dot tile height. Then we'll go down and we will update this object right below grid. So we'll say mouse cursor dot update dt, and then we will draw it down here. We'll say mouse cursor dot draw G2. Let's see what happens. Fingers crossed it will work. Okay, so we get nothing. There's just nothing on the screen. Let's see what's happening. So the problem was we weren't even just adding it to the mouse cursor. So if we say mouse cursor dot add component, and then we give it the mouse sprite, now we should be able to see it. We didn't have anything attached to the mouse. That's why it wasn't going. Cool. So we see whichever square I'm in, the sprite follows, and it snaps to this grid, which is really nice. Right now, if you click, it doesn't do anything. So that's going to be the next thing we do real quickly, which is just when you click, it places an object in that grid. So let's do that. We'll go into snap to grid, And then inside of the update loop, first we'll say if window.mouseListener.getWindow.mouseListener.mousePressed. And we do want to check a couple other things, like if it's above the ground and stuff. We'll do that in a second. For now, let's just get this working. So if the window.mouseListener is pressed, and then we say, we'll say GameObject. This could be the new object, object equals, and we're going to do, we could do this dot copy, which would just copy everything and then remove the component snap to grid because we don't want it to stay. So let's actually do that. We'll say GameObject equals GameObject dot copy, and then we'll implement this real quick. So let's go to our GameObject class, and then we'll go into here. We'll say public GameObject copy, and then what we need to do is we'll say GameObject new GameObject equals a new GameObject. And then we'll give it generated because this has been generated, and then the transform will be a this transform.copy. Do we have a copy for that? No. Let's add a copy of the transform too, because these are useful functions. So go into transform, and then we'll say public transform copy, and then this will return a new transform. We'll actually do it. We'll say first transform equals new transform, and then we will give it this dot position dot copy. We don't have that as a copy either. We will need this too. So the reason I'm doing these copy functions too and not just saying equals is because in Java, if you do that, it will actually just assign a reference, and so you won't be copying values around. What you'll be doing is just messing with the same object, which could lead to some really weird bugs. So we definitely don't want to do that. So say return new vector2 here, and then we'll just give it this dot x and this dot y. There we go. And then transform, that's good. Then we'll say transform dot scale equals this dot scale dot copy, and then transform dot rotation equals this dot rotation. The only thing you can say equals with are constant values like this. So classes you cannot just assign, but if you do like floats, integers, booleans, those will just be copied. So those are the only ones you can really do with that. Then we'll say return transform, and then we'll go into GameObject, and so it's copied that GameObject now, or the transform, and then we'll go into here and we'll say new GameObject. We want to add all the components, so we'll say for component C in all of these components, we'll say new GameObject.add component C.copy. Let's go to our component class now. These are some important methods too that we should have been adding, but we didn't. So we'll say component copy, and let's actually make this abstract. We need to force every single class that derives from this to copy that. So now we're going to have to go through all of our components and create a copy. So right here, this is just going to return null because, well, we'll return a new box bounds for now with the width and the height. Then we'll go to camera controls. And I just realized that I've been doing this whole tutorial outside of presentation mode, which means the text is really small. Let me fix that real quick. So sorry about the beginning of the tutorial. Completely forgot to do this. Okay, so let's go into here. We will create the copy method here too. So we'll say return, whoops, go into here. This is component now. Okay, go back to the camera controls. Copy should just return null, that's fine. Go into grid, let's implement this, and then returning null is fine. Go into ground. The reason these are fine being null is because we probably won't need to copy these, so I'm fine with that. To player, copying this is fine if it returns null. Rigid body we might actually want to implement. Actually no, player is the only rigid body, so we should be good with that too. Snap to grid, that's fine as well. Sprite, this one we will want to, the sprite has a buffered image, a picture file, and the width and the height. So with this one we should be fine to just return a reference. So we'll actually just say return this, because we don't want to be copying these ones since they have a lot of data attached to them, the image. It's the whole reason we created the asset pool. So this should be good, and then we'll just be copying references and stuff. So okay, sprite sheet is not a component, so we're good. Cool. Now that we have the copy done, we can go into GameObject. This should be fine. And then what we'll say is return new GameObject. Okay, there we go. All that was for this snap to grid. Okay, so now we have, if the Windows mouse listener, we create the object, which is just object.copy. And let's say object.remove component, which is another one we don't have yet. And then we will say it's going to be snap to grid dot class, because that is the class we want to remove. So this is going to be very similar to the add component method. Go to game object. So, well, very similar to actually get component. So we'll make it right below here. Public void remove component C, and then we're just going to go loop through the component. So we'll say we're actually not even going to take in a component. I'm going to copy this because we want to take in something very similar to this. So we're taking in a class. So yeah, we do need this, and we'll just say copy, paste that right there. So we have this abstract. We're making this method abstract, sort of like we did with this one. Then we will just basically say for component C in the components, if C dot get class. Well, we'll do this. We'll say if, we'll literally just copy and paste this one. But then instead of returning the component class cast, we will just say return right here. After we remove it, of course, which is, we'll say components dot remove C, and then we'll return. This way we don't get an error with modifying this while running through it. We shouldn't. We'll check and make sure. So we go back to here and we have no error, and we will just say, so we have this object, and then this object should have copied all the state. Should work. Let's just run it and see what happens. So if we run this and I click, we get an error, and it says right here, add component null pointer exception. So which one are we trying to copy? And that is the snap to grid. Okay, so I said we don't need snap to grid because it's null. That's pretty good, because then we won't have to remove this. We can just go into our game object and build in, when we're copying it, instead of just adding all of them, we'll say if c.copy does not equal null. So we'll do this. Then we'll add that copy. And then what we'll do actually is we'll just say component copy equals c.copy. And then if this copy does not equal null, we'll just add the copy. And then we don't even have to worry about removing the component afterwards too. So if we go back to our snap to grid, we can actually just remove this. Oh, I think I already did, yeah. So we just removed it, and then that should be good. So we go back into here, and if I click, cool. But we have a problem, and that is that it's just moving around with the mouse. And I think that is probably because of us passing a reference to the sprite instead of passing new data. The issue is actually pretty simple. So we were copying the reference, so that is important. If you go into your sprite class, you should change it to do a new sprite with this.image, which will use this. So we won't actually copy the data. We will hand the data around as a reference, but we will have a separate sprite object, which is important so that we can just differentiate between the objects and they're not all sharing references. But then we also have to go into our snap to grid class. And this was kind of important too. We have to say window.getWindow.getCurrentScene.add game object, the object we just created, because otherwise it's not even adding it to the scene. It's just staying around. So now if you click in place, that's a glitch too. Almost, we're almost there. We get this weird glitch, but we're sort of placing items. And the reason for that weird glitch is because we're saying if the mouse is pressed, but we're not checking which button. So we'll say and window.getWindow.mouseListener.mouseButton equals mouse event dot button, and then we'll say 1. So we just want to import that one, and then we'll go down here and just move that to a new line. So if we run this one more time, and now if we move, it doesn't start placing items, but we do see it's still sort of weird placing objects in the wrong place in relation to the camera. So what's going on with that? The problem is actually, if you recall, what we're doing is we're transforming the X and Y slots relative to the window space. But what we should be doing is once we copy the object, we actually need to transform this back to world space. So we'll say the object's transforms position is actually a new vector 2, and then we'll just say X times grid width and Y times grid height, just to transform it back to world position so that it's drawn in the correct place. And if we move and we place, we see it's good. There's one more problem that we need to fix real quick, and that is you notice that it gets really dark really fast. These are actually sort of transparent blocks, and the reason it's doing that is because when we click, we're actually placing like hundreds of these down at a time because we're not using that debounce. So to fix that, we can say up here, debounce left minus equals delta time. So how much debounce time do we have left? And then we can say if this is null, and then if the mouse listener is pressed and the button is 1 and debounce left is less than 0. So then we'll go up to here, and then we will go into here and we'll say debounce left equals debounce time and reset that so that we can click again. Whoops. And then we'll build this and run it real quick. And if we click, there we go. See how it's a lot less transparent. And then we click and we're placing these over the world. So this is sort of the first step into actually building our game world. We can now click, and if you click and drag, places multiple without, placing them in the same spot. If we do hit it over and over and over again, notice it does get darker. That'll be something we'll fix once we add box bounds and stuff to check and see if there's anything where we're trying to place it. So this concludes this tutorial. In the next tutorial, what we'll go over is we'll actually go over starting to add some buttons and stuff and fixing things like this. We shouldn't be able to place blocks down there. So that we can actually change the type of block that we're placing. Hope you guys like this. If you did, please hit like and subscribe, and I'll see you next time. Thanks. See ya.